Out here, beyond Mars, beyond the asteroid belt, far from the warmth of the sun, you would expect silence. You would expect a frozen graveyard of rock and ice, moons locked in stillness, surfaces untouched for billions of years, craters preserved like ancient scars. That is what distance from the sun usually means: cold, darkness, inactivity. But then NASA pointed its instruments toward Jupiter's inner moon, Io, and everything we thought we understood about frozen outer worlds began to fall apart. Because Io is not silent. Io is not frozen. Io is violently alive. From orbit, Io does not look like a typical moon. It looks wounded. Its surface is stained in impossible colors: sulfur yellows, deep reds, ghostly whites, strange greens. It looks less like a moon and more like a world caught mid-explosion. And in many ways, it is. When NASA's Voyager 1 spacecraft first flew past Jupiter in 1979, it captured something no one expected to see. Rising above Io's horizon were enormous plumes, towering eruptions blasting material hundreds of kilometers into space. Volcanoes. Not ancient, not dormant, active. That discovery alone rewrote planetary science. Until that moment, Earth was the only place in the solar system where active volcanism had been confirmed. Suddenly, a small moon orbiting a gas giant had stolen that title. And not just with one or two volcanoes. Io has more than 400 active volcanic centers. It is the most volcanically active body in the entire solar system.
So how is that possible? Io is nowhere near the sun. It receives only a fraction of the sunlight Earth does. Solar heating cannot explain rivers of molten lava and lakes of fire. The answer lies not in heat from above, but in force from all sides. Io orbits just 350,000 kilometers above Jupiter's cloud tops, roughly the same distance between Earth and our own moon. But Jupiter is not Earth. Jupiter is more than 300 times the mass of our planet. Its gravity is overwhelming, and Io sits dangerously close. Close enough to feel the pull constantly, but not close enough to fall in. This is where the violence begins. Io does not orbit Jupiter in a perfect circle. Its orbit is slightly oval, stretched by the gravitational tug-of-war between Jupiter and the other large Galilean moons, Europa, Ganymede, and Callisto. Every 2 days, Io swings closer to Jupiter, then slightly farther away. Closer, farther, closer, farther. With each pass, Jupiter's immense gravity squeezes Io. Not metaphorically, literally. The solid rock of Io rises and falls by as much as 100 meters. Imagine the entire crust of Earth bulging upward and downward by the height of a 30-story building every 48 hours. That constant stretching generates friction inside the moon's interior. Friction creates heat. Not surface heat, deep internal heat. This process is called tidal heating, and on Io it is extreme. Instead of a calm, rocky crust sitting quietly over a stable mantle, Io's interior is constantly being kneaded like cosmic dough. Energy is pumped into it over and over again. That energy has to go somewhere, and it escapes through fire.
Io's volcanoes are not like the ones on Earth. There are no tectonic plates colliding to push mountains skyward. There are no classic cone-shaped peaks built slowly over time. Instead, Io's crust cracks under stress. Lava erupts from fractures in the surface. Some eruptions throw molten material dozens of kilometers into the sky. Above that, sulfur-rich gas plumes can rise hundreds of kilometers high. So high they briefly escape the moon's weak gravity before falling back down like glowing snow. And what falls back down reshapes the entire landscape. Sulfur dominates Io's surface chemistry. Bright yellow plains are made of crystallized sulfur, frozen by extreme cold away from volcanic zones. White and bluish patches are sulfur dioxide frost, frozen deposits collecting in shadowed regions. Green tones form when sulfur compounds interact with Jupiter's intense radiation environment. And the red regions? Those are hotspots, areas where lava still glows beneath the surface. Io is not just erupting, it is constantly repainting itself. One of the most dramatic features on Io is a massive lava lake called Loki Patera. It spans roughly 200 kilometers in diameter. That is large enough to swallow entire metropolitan regions on Earth. In its center sits a solid island of crust surrounded by a churning ocean of molten rock. Unlike Earth, where magma chambers lie hidden below the crust, Io often exposes its molten interior directly to space. But here's something even stranger. Despite this overwhelming volcanic activity, Io does not appear to have a global magma ocean beneath its crust. Spacecraft measurements of Io's gravity field suggest that molten regions are not evenly distributed. Instead, they exist as localized pockets, hundreds of independent volcanic engines operating beneath the surface. Each region flexes differently, depending on how strongly Jupiter's gravity pulls on it. Each volcano behaves in its own way. Io is not powered by one great furnace, it is powered by countless smaller ones. And then there are the mountains. Io's mountains are among the tallest in the solar system. Some rise 18 kilometers high, nearly twice the height of Mount Everest. But they do not form in ranges, they stand alone, isolated, jagged.
As if they burst from the ground suddenly, NASA's Juno spacecraft, which arrived at Jupiter in 2016, captured some of the most detailed images ever taken of Io during close flybys in 2023 and 2024. It came within just 1,500 kilometers of the surface. What Juno revealed was a world that looks alien even by space standards. One structure, nicknamed Steeple Mountain, rises sharply like a blade piercing the sky. Scientists believe these mountains form not through gradual uplift, but through collapse and compression. When large lava lakes drain or crust collapses downward, nearby rock may be forced upward violently. Imagine a sinkhole forming, and instead of a depression, a mountain erupts beside it. Io's surface is in a constant state of rise and fall. Unlike our moon, whose surface preserves ancient craters from billions of years ago, Io's terrain is continually recycled. Craters rarely last long. Lava buries them, sulfur coats them, new fractures open. The landscape you see today may not resemble what existed even a few million years ago. Io is young, not in age, but in surface memory. And yet, despite its violence, Io has no oceans, no thick atmosphere, no signs of life. Its atmosphere, composed largely of sulfur dioxide, is thin and unstable, expanding and collapsing depending on volcanic intensity. It is not a place built for biology, it is a place built for physics. And that may be what makes Io so important. Io shows us what gravity can do, what happens when a world is trapped in the shadow of a giant, what tidal forces are capable of when pushed to extremes. And perhaps most importantly, Io teaches us that distance from the sun does not guarantee stillness. Life may not exist there, but motion does, energy does, chaos does. For billions of years, Io has been locked in this gravitational dance with Jupiter,
pulled, stretched, heated, erupted, again and again and again. Future missions like Europa Clipper and the European Space Agency's JUICE spacecraft will explore other Galilean moons, searching for subsurface oceans and potential life. But Io remains the wild card, the outlier, the moon on fire. And perhaps one day, when we return with new technology and new questions, we will uncover even more about this restless world. Until then, Io continues its violent orbit, reshaping itself under Jupiter's relentless pull. A moon that should be frozen, a moon that should be silent, yet instead, it burns.